Hey everyone, in today's video we're exploring rate limiting, a critical strategy to prevent services from being overwhelmed by too many requests from a single user or a client. If you have ever wondered how APIs and web services stay responsive under high traffic, rate limiting is a big part of the answer. So let's dive in. First, what is rate limiting? Rate limiting is about controlling how many requests can be made to a service over a specific time. This helps prevent overload, like stops a single user or attacker from sending too many requests and crashing your service. Number two, maintain fair usage, like ensures that resources are evenly distributed among all users. Number three, improve stability, keeps your service responsive even during traffic spikes. Essentially, it acts like a traffic light, letting requests pass and at a control pace. Okay, we have some basic steps of rate limiting. First, we count the incoming requests. Track how many requests each user or client is making. After that, in the rate limiting, we will compare them to the limit. Like if a request exceeded a threshold within a specific time frame, we take an action, maybe block or throttle. And after that, we enforce limits. We deny requests or slow them down once the rate limit is reached. So in this example, we compared the limit and the limit was only 2 requests. So we passed 2 requests and the third one was dropped. Okay, but how this is done? There are multiple algorithms to handle that. First, we have the token bucket. It allows for bursty traffic while enforcing an overall rate limit. A bucket of tokens refills over time, and each incoming request consumes a token. The pros of this algorithm, it can handle short spikes without penalizing overall throughput. The cons or the problem, it doesn't always produce a perfect even flow. Number two, we have a leaky bucket, and we take this from Algomaster. Big shout out for them. They are great. They are great blog post channel. In the leaky bucket, we enforces a constraints requests rate by processing requests one by one or at fixed rate. The pros of this one, it's smooth out traffic, easy to visualize as water leaking from a bucket. The cons of this one is can be too strict if you need to handle brief bursts of traffic. Next, we have fixed windows or fixed window counter. It limits requests in fixed time intervals, like 100 requests per minute. The pros, it's a very straightforward to implement. The cons, it can cause a burst problem at the boundary between two windows. Next, we have the sliding window log. Tracks timestamp of requests in a rolling window, ensuring requests don't exceed the limit within that period. The pros of this one, it's more accurate reflection of users' behavior over time. The cons, it requires memory to store timestamps, which can be large if a traffic is high. And there is something which combination between both of them, which we call a sliding window counter. It's like we use a hybrid approach. It's a similar to a fixed window, but smooth the rate between adjacent windows. The pros of this one is less overhead than storing every request, but more flexible than a simple fixed window. The cons of this one, implementing the partial window can be slightly more complex. It's not easy. Okay, if you want to choose the right algorithm for you, what should we do? Okay, How to decide that? First, let's talk about traffic patterns. Like, do you need to allow short bursts? Number two, implementing complexity. Like, some methods need more memory or more complex setup. You need to think about that. Number three, accuracy needs. Like, do you want an exact rolling window, or is a simpler fixed window enough? Often, token bucket or sliding window methods strike a good balance between burst capacity and consistent enforcement. You find yourself using them most of the times. Okay, we need to make some consideration. First, where to enforce the rate limiting. It's at an API gateway, load balancer, or within the application code. Okay, we need to talk about the distributed systems. If you have multiple instances or microservices, you will need centralized or synchronized rate limiting mechanism to handle everything. Also, feedback to users. You like provide a clear HTTP status code or error messages like 429, which means too many requests. And we have monitoring and logging. Like, track how often users hit the limit, which helps tune your rate limits over time. Okay, I guess we can wrap everything up now. Rate limiting is one of the most common algorithm. Sorry. Okay, so there you have it. A quick introduction to rate limiting and the most common algorithms used to implement it. Where you're building an API or microservices architecture, rate limiting is a must-have tool in your performance and security toolkit. Thanks for watching this video. If you found this video helpful, give it a thumbs up and subscribe for more content on system design and the backend best practices. Let me know in the comment section which rate limiting algorithms you prefer, and I will see you in the next one. Stay tuned.